Howdy, physics sleuths and inquisitive souls. So, in this episode, I want to go over antimatter. Um, it has the exact opposite characteristics of regular matter, as I'm sure most of all of you know. And there's still a looming question, though. It's never been settled yet. Soon it will be. Whether antimatter has the opposite effect that gravity has on regular matter. We just don't know. All the theories pretty much say that it should have the exact same effect as regular matter. At least according to general relativity and pretty much every other theory. They all agree to some level or another that gravity essentially works like kind of like this space-time diagram. And so it doesn't matter, according to Einstein's weak equivalence principle, which just basically states that gravity is always going to work the same no matter what frame it's in. It's never going to change. That's essentially what it's saying. And so let's say this little red dot is antimatter, right? And this orange one is matter. And this is our source of gravity, celestial body. This would hold true because the matter is going to put weight on space-time, which is going to create the effect of gravity, allegedly. And then the antimatter is going to do the same. It doesn't matter what it's made of. As long as it's made of stuff, it's going to affect space-time in the same way. So Einstein says. Now, those who follow this channel know that I might have something different to say about this. And this is pretty ballsy statement to make here, but according to my theory of gravity, because it's created from displacement of the electromagnetic force within the atom, it's going to have the exact opposite polar effects antimatter will. And so according to my theory of gravity, a proton is actually not going to fall in a gravitational field. It's actually going to be really unstable, if not just shoot straight up to space. You would think that in this day and age, we would have done an experiment to definitely verify that this is the case. But there is no such experiments. I've always looked for years and years. I've never been able to find one. There's been a lot of experiments that have been done on how gravity affects protons and antimatter so far, but there's nothing that's been able to determine whether even just a basic proton falls in gravitational field or not. Now, actually, a funny fact, the way we know about the mass of the proton is it's calculated from the neutron, which they can easily measure. So they know that a neutron is just a proton that is eating a electron. And so they just added the two masses together or subtract it, from the neutron, and now you have the mass of the proton. That's how they know how much the proton weighs. This has never been experimentally observed in any laboratory. Now, like I say, they've done experiments, so they know that protons are affected by gravity. And antimatter as well now. But the claim has long since been that the proton is the most unstable particle in all of known physics. It so desperately wants to pair off with a electron or even a neutron that any environment you have it in is just going to react with that environment. So even if you have like a vacuum, the proton is just gonna, head towards the walls, whatever chamber you have it hidden in, and react like the most powerful acid you could ever imagine. Just eating away at those chamber walls and stripping electrons away from whatever your chamber's made of. So, yeah, it's definitely it's something that you would think that we would have had sorted out by now, but we don't. So, according to Einstein, all matter is going to have a gravitational attraction no matter whether it's antimatter or not. According to me, because the way that matter or gravity is generated, antimatter is going to have the exact opposites of the characteristics of matter in a gravitational field. Well, probably. I mean, there could be something really weird going on, but I doubt that. A positron especially. A positron is a lepton. It's a fundamental particle. It cannot go any further. It cannot be broken apart or divided. So especially for the positron, I feel that it would have the exact opposite effect than an electron has in matter. We know electrons fall, so a positron must rise or be unstable, do whatever it does. So this means that if we have, let's delete this. If we have a proton and an electron, right, and they're kind of, bounded to each other through the electromagnetic force. If it's a antiproton and a positron, the antiproton is going to be attracted to, let's say, the source of the gravity, say Earth. Let's say this is Earth. So we know that this is going to fall. If Einstein is right, all matter is attracted to all matter, and these are always going to fall, whether they're antiprotons or not, according to the weak equivalence principle. And if that does not happen, then general relativists have some explaining to do. So, according to my theory, because a regular proton shoots up into space, or it goes the opposite direction. We've just been unable to measure this in a laboratory because they're so reactive, and scientists have no reason to believe, according to Einstein, that a proton wouldn't be attracted to a source of gravitation. So they don't even really try and devise serious experiments to 100% find out what they believe they already know. But let's say this is antiproton. It's going to fall towards the gravities, right? And so you're like, well, hold on. You said anti-gravity or anti-matter is not going to fall. It's not going to be affected by gravity. And that's true, because the positron, which is where the most, or the electron, the positron, electron, whatever, where the most of the force is being done, and for reasons I don't even understand, this would go deep into quantum mechanics or, something. It goes beyond me, but this is the way it is. And so the Earth's gravitational field is going to repel this positron upwards away from it to get stability, but it's going to pull on the proton. So what's going to have the bigger effect is the anti-positron. And so the entire atom as a whole, whether it be anti-hydrogen or anti-lithium or anti-calcium or whatever, is going to go away from the source of gravity, according to my theory. Now, this is a big deal because this is a prediction that my theory has that no other theory has. No other theory. And as it turns out, they are doing experiments at CERN, alpha experiments, one in particular called Alpha G that we really want to take control over. And that is going to test just that. They've already done kind of a pseudo test of it. And what they can say from that data, I think it's not having the effect they want it to, so they might be delaying the results, but that's just my personal opinion. But basically, they've already done a test to see, and I think here's a paper on that, measurement of the antiproton to proton charge mass ratio. That's the actual paper from Nature about it, where it's basically saying, yeah, here is an article on it, probably more lamest for you guys to understand, that they measured that antimatter behaves the same strength-wise to gravity as regular matter does within a 3% tolerance, within a 3% measurement. That they can go so far. They're going to get more and more. I think they've actually have gotten further than this now. So they know it's established antimatter is definitely affected by gravity, but they've been unable to determine whether that effect is positive or negative. Like what the polarity of the gravity is, what they've been unable to test yet. And the experiment that they want to do is called Alpha G. And they're basically, I think this is a picture of it, they're basically going to trap a bunch of anti-protons with anti-positrons. So it's going to be, they say, anti-hydrogen. So anti-hydrogen is going to be trapped in like a magnetic cold storage, thing. And they're going to be able to see, to detect whether the anti-hydrogen is going away from the Earth or is it falling towards it. So whether it's affected by gravity all the same. And this was supposed to be done, like you say, here is an article on it in 2018. I think 2017 is when they really started working on this, trying to get everything set up. And they thought at the time that it would only take a few years to do this. But then COVID happened and it shut, CERN down, and then they shut it down to beef up, to ratchet down and make it more powerful than it's ever been before. And so now they're finally getting back, and they're trying to hash through this to find out what the results of this experiment are going to be. Does antimatter, like anti-hydrogen in particular, fall in the gravitational field like all other matter, or does it do something different? So if they establish that an anti-hydrogen behaves the exact same way as a hydrogen molecule or atom in a gravitational field, then that's going to be a huge downfall of my theory of gravity. That might just do it in altogether. Like that just straight up might do it in. Like I might just hang up the hat and be like, you know what? I thought I was onto something, but the one experiment that definitively decides whether my theory is correct or not comes back and says, nope, I'm wrong. I might have to I might have to reevaluate my entire life up to this point and drop this theory of dynamic gravity, which I'm hoping I don't have to do. That would really suck having to start over again after I've gotten a theory that explains so much of everything. And but on the flip side, if it's discovered that anti-hydrogen does not behave the same way in a gravitational field as hydrogen does, that pretty much does end general relativity. Like there is no getting around that. Like it's your entire theory is based around the weak equivalence principle, which says that gravity behaves the same in all frames, no matter what it is, no matter where it is. So if that's not the case, then your entire theory is now in question. So there's a lot on this writing on this experiment, and I'm really upset that it's been like 5 years now, and there's still no definitive answer. It makes me think that maybe they're not getting the results that they want or they thought they were going to get, and they're just trying to hold on that data as long as possible to try and figure out what's going on, to come up with an explanation themselves so they can get a Nobel Peace Prize for it. This is just the way science works, unfortunately. Scientists are brutal like that. So, and here's the weak equivalence principle. And like I say, it just states that, it all should behave the same as far as gravity is concerned, because you say space-time causes gravity. So there should be no difference. It should all be the same. And this is an article explaining when they did the first test, I think 2 years ago it was now, where they determined that gravity, or that matter and antimatter both behave to the same strength and degree from gravity, but they cannot tell you what the polarity is yet. They're still working on that, and we're going to find out soon. Hopefully in the next year. I'm hoping 2 years tops. This could be huge. This could definitively prove beyond a shadow of a doubt my theory of gravity is 100% correct and Einstein is 100% wrong, or vice versa. So there's a lot at stake here. If you guys are, if you don't buy into general relativity, like I do, definitely this is an experiment you want to stay on top of, and you want to know the day the results are released. You want to know what the results are, because this is going to tell us a lot about gravity. This is huge. One of the biggest tests, as far as I'm concerned, scientific tests we've ever done regarding general relativity. I know there's been some other ones like time dilation and, the warping of space-time or whatever, from gravity. But this is the one that actually legitimately, I believe, could do it in. So there you have it. I hope I explained to an adequate degree what's going on with this test and why it's so important, and how it's literally going to make or break numerous theories of gravity, mainly mine or Einstein, or all of them. If anti-hydrogen doesn't behave, they're all wrong. None of them have an explanation except for me, and mine's the only one. The only one that can tell you what's going on there on a subatomic level, on how everything is working together. It's the only one. So I hope it's right. I really do. If not, that's going to be a really bad day for me. But, I look forward to it. The truth is nothing to be scared of. So hopefully soon enough, we are going to see the truth regarding gravity from this CERN Alpha G experiment. And I can't wait to talk to you guys about it when it happens, for better or for worse. So hope you guys learned something here and keep up to what's going on. And have a good day. Bid you farewell.
Like, subscribe, submit.